let's look at how to solve simple equations. So what equation does the balance model below represent? Well, I have x's and I have, we'll call these units of 1, and then I have units of 1 over here. Well, I have 4 x's and I have 8 1's, and on the other side, I have 32 1's. So 4 x's and 8 1's is the same as or equal to 32 1's. So how do we figure out x using this model? Well, we take 8 away from both sides so that we're trying to keep this whole thing balanced, right? If I take away 8 from here, I need to take 8 away from here. And then I need to then take however many x's away. If I take away so that I have 1 left, I would then have 4x is equal to 24, and I divide both by 4, and I would have 1x is equal to 6. Put that in here. X is then equal to 6. So one block of x is the same as saying 6 of those individual 1 units, right? The whole thing, the whole idea is to kind of keep this equation balanced. What we do to one side, we have to do to the other. So solving equations involving adding and subtracting. Well, I have x plus 4 is equal to 13. Well, how do I solve for x? Well, I need to get away this addition of 4. So how do I get rid of the 4? Well, the opposite operation of addition is subtraction. So I need to take away 4 from that side. But again, I got to keep this whole thing balanced. So if I take away 4 from this side, I need to take away 4 from the other side. So now I have x by itself, and then 13 minus 4 gives me a value of 9. So that a x value is 9. X minus 8 is equal to 2. How do I get this? Well, if I now think about it as I need to get rid of this negative 8. So I need to isolate x, or have x alone. If I take 8 and I just bring it over to the other side, if I just take this and bring it over to the other side here, the sign needs to change. Sign must change. So if it was a negative 8, it is now a positive 8, and we can see that here. So then I have x by itself, and then 2 plus 8 is equal to 10. Either way that you want to look at it is an acceptable way to do it. Negative 4 plus x is equal to negative 1. Well, I have a negative 4. I need to add a 4 on both sides in order to eliminate this. So I have x is equal to 3, because I have negative 1 plus 4. Solving equations involving multiplying and dividing. I will have 3y is equal to 18. Well, how do I get y isolated? It's being multiplied by 3, so therefore the opposite operation is division. What I do to one side, I must do to the other in order to keep things balanced. So these 3's cancel, I'm left with y, and then 18 divided by 3 gives me a value of 6. All right, the same thing kind of over here. We have n divided by 3 is equal to negative 4. Well, what's happening to n? It's being divided by 3. What is the opposite operation of division? Well, it's multiplication. So I would need to multiply it in order to eliminate that 3. So then these are canceled. I'm left with n is equal to whatever negative 4 times 3 is, which in this case is negative 12. So some of the language you might hear, a root is the value of the variable that makes the equation true, right? It's what the variable actually is. Solve means find the value of the variable. So when we're looking at two-step equations, we are doing BEDMAS, but we're doing it in reverse at each step. So quick refresh, what is the opposite operation of addition? Subtraction, multiplication, and division. Well, we know this. Opposite addition is subtraction. We know the opposite operations. The opposite operation of squaring something is taking the square root. What is the operation of raising anything to an exponent? Well, the opposite operation, it's being raised to an exponent. I take whatever that exponent is, the nth root, right? So what that means, if I take something like x to the power of 4, the opposite is the 4th root of x to the 4th. That way those would cancel out. What is the opposite of square root? Well, that's squaring. And what is the opposite of the nth root? Is the nth exponent. Right? So if I have something, if I have an equation such as like the fifth root of 284, well, the opposite of that would be equal to fifth root of 284 all to the power of 5. That way, these can cancel out. So, quick example, solve. So I need to find the value of the variable. 5x plus 25 is equal to 500. Well, I need to isolate x. What's happening to it? Well, there's a 25 being added to it, so I need to take that away. So what I take it away from one side, I have to do to the other. So this becomes 5x, but on the right side, it becomes 500 minus 25. Now I have x being multiplied by 5. What is the opposite operation? Division. So 5x divided by 5. What I do to one side, I have to do to the other. 5. So then I'm left with x is equal to 475 divided by 5, which in this case is 95. You will also be asked to check your answer using a left side, right side check. So you cannot just plug in the number of the equation. So what I did was I took the equation. I have the left side of the equation, which is 5x plus 25, and the right side of the equation, which was 500. I then plug in my value of x into the equation to make sure that it balances. So in this case, it's 95. So 5 times 95 plus 25 is equal to 500, and the right side is 500. These are both the same, or it's balanced. Therefore, that is a proper check, or we know that we got the correct answer. The best part of solving equations is that you can always check your work, right? So you can always kind of work backwards, which is essentially what I did right here. You can work backwards in order to determine whether or not you got the correct answer, okay? So if I quickly solve for, well, x squared, how do I get x by itself? Well, I need to take the square root of x squared is equal to the square root of 16, right? I need to do what I do to one side, I do to the other. So these, the square root and square cancel, so I'm left with x, and then what is the square root of 16? It is 4. Same over here, we have p to the power of 3 is equal to 27. What's the opposite operation of taking a variable and raising it to the power of 3? It's taking the third root of it. So third root of p3 is equal to the third root of 27. So these cancel, and I'm left with p, and then the third root of 27 is 3, or what number multiplied by itself 3 times gives me 27. All right, I have the square root of n. How do I figure this one out? Okay, what's the opposite operation of square rooting? Square root of n, and I take this and I square it. If I'm going to perform this math on the left side, I need to do the same thing to the right side, which is also the same as saying 9 squared. So then the roots cancel and the exponents cancel, and I'm left with n, and then 9 squared is 81. And last one here, I have the third root of h. So what do I have to do to it? The third root of h, how do I cancel that? I raised it to the power of 3, which then I have to do with my negative 2 to the power of 3, right? So I'm left with now with h, negative 2 times negative 2 times negative 2. Well, there's 3 negatives, and I'm going to have a negative. 2 times 2 is 4 times 2 is 8. So now we're going to change the equation to the form x equals, or how do we rearrange it so that x is isolated? Well, in this case, what's happening to x? It's being multiplied by 2, so I need to divide it by 2. What I do to one side, I have to do to the other. So x is then equal to y over 2. Second example, y is equal to x plus 50. Well, what's happening to x? 50 is being added to it, so I need to take that away. So if I take away 50 from one side, I need to take away 50 from the other, and I'm left with y minus 50 is equal to x. All right, last example here, for the third example, I have y equals 2x minus 80. What's happening? Well, there's an 80 being subtracted from it. I need to add an 80. So I have y plus 80 is equal to 2x. Now what's happening? Okay, well, it's being multiplied by 2. Opposite operation is division by 2. By 2. So now I'm left with y over 2. What's 80 divided by 2? It would be 40 plus 40 is equal to x. Write an equation that tells you how to calculate t if you know m. So isolate t given the fact that we're going to know what the m value is, right? So I just need to rearrange this. So let's ask ourselves, what's happening to t? Well, it's being added 10 is being added to it. So I need to take 10 away. M minus 10 is equal to t. For b, I'm looking at 4 multiplying t, divide by 4. So m divided by 4 is going to be the value for t. M equals 3t minus 9. I need to take away 9 away, add 9, pardon me, to both sides. So then I have m plus 9 is equal to 3t. Divide both sides by 3 because I need to isolate my variable of t. So I'm left with t, m over 3, and then 9 divided by 3 gives me a positive 3. And our last one here, well, I have t being multiplied by 4. The opposite operation is division. So then I divide. 3m divided by 4 is equal to t.